Hello friends, today I am going to discuss about the next topic, that is in the previous topic we discussed about the interest formula, that is the single payment series and uniform series. In the single payment, two equations: single payment present worth and future worth, present worth and future worth. Then in the uniform series, the four equations, that is future value, sinking fund, uniform series present worth and capital recovery. That is totally six formulae. In continuation of this, so one more is a uniform gradient series. The uniform gradient series is nothing but the amount deposited or amount cash inflow or the cash flow outflow, it is uniformly varying. The same amount is varying every year, every interest period. That is in the beginning, it may be in the first on the compounding period. So one amount, that is 1000 rupees if it is deposited. Next second year 1200, next third year 1400, 1600. The same amount may be the increment or decrement. That is known as the uniform gradient series. Okay, so the objective of this uniform gradient is a series mode of investment is to find the annual equivalent amount of the series with the amount A1 at the end of the first year and with an equal increment G at the end of each of the following n-1 years with the interest rate I compounded annually. Here, so the first you have to convert this gradient into the same amount, uniform A, that is uniform series. From the uniform series you can convert into present value or the future value. Present value, future value can be converted. Okay, first the gradient should be converted into the same uniform amount every year, the same amount. For this there is an equation A equal to A is the annual amount, that is converting the gradient into the annual amount, uniform amount. A equal to A1 is the amount deposited or withdrawn at the end of the first year, that is A1, plus G is the gradient amount, that is the amount, the increment amount every year, that is the same constant amount G into 1 plus I to the power n. I is the interest factor, sorry, interest, and n is the number of interest period. I 1 plus I to the power n minus I into n minus 1 divided by I into 1 plus I to the power n minus I. This is the equation. Or from the table we can take so that is A1 plus G into A by G I n, where A by G is a factor. Okay, this is A by G I n is called as a uniform gradient series factor. Let's see the example. One example, we'll solve on the numerical problem. Here, a person is planning for his retired life. He has 10 more years of service. He would like to deposit rupees 4000 at the end of the first year, that is 4000 at the end of the first year, and thereafter he wishes to deposit the amount, so the same amount with an annual increase of rupees 500 for the next 9 years. That is the first year 4000, next 4000 plus 500, 4000 plus 1000, like this, that is 4500, 5000, 5500, and at the end of the 10th year 4000, sorry, plus 4500, that is 8500 rupees. That is with the okay, 500 for the next 9 years with an interest rate of 15%, and I is 15%. Find the total amount at the end of the 10th year of the above series. And at the end of the 10th year, what is the total amount, that is F, you have to calculate. Okay, to calculate F, first you have to convert this into gradient factor into the uniform series A. Okay, that is the variation should be converted into the A. Okay, annuity. Okay, annual. So then, so this from the annual, then you can calculate the future value, that is uniform series future value. That is two equations we need. So here A1 is the initial payment, it is 4000 rupees. Initially 4000 is paid. Then the gradient factor is 500. Every year increment is a 500. The same amount is increment of 500. The interest is 15%. Then number of years 10. So you can find. So how to find? First you have to find A and F. The A can be calculated. A equal to A1, the initial payment, plus G, gradient factor is 500. 1 plus I to the power n minus I n minus 1 divided by 1 I into 1 plus I to the power n minus I. Or you can take the value from this table, A by G I n. Okay. So you'll get the value of A is 5 lakhs 5691.6. That is, it is equivalent to, it is depositing 4,000 first year, then the 4,500 second year, 4,000 5,000 third year, then the 5,500 fourth year, etc. It is equivalent to depositing 5,691.6 rupees every year for 10 years. Okay, that is a gradient. Gradient is nothing but converting this the varying payment into the equal payment. 5,691.6 rupees. That is, this is equivalent to paying an equivalent amount of 5,691 rupees at the end of every year for the next 10 years. Then you can calculate the future value. The future worth of this calculated. So using the the uniform series future value, that is F equal to A into F by A I N. Okay, this factor. Okay, A into F by A, 15% 10. Okay, 10 years. Okay, therefore the future value is 1,15,562.25 of this deposit. Okay, of this deposit, that is at the end of 10th year. So the investor, okay, that person will get 1,15,562 rupees. Okay, with this investment. Okay, this is the gradient factor. Okay, the gradient factor, usually first you have to convert the gradient into annuity or uniform series, then uniform series to the future value. So if you want to calculate the future value, then the future value, or if you want to calculate the present value, convert into present value. Okay.